we are asked to solve the quadratic equation by completing the square. The first step is to write the equation in the form shown here, which for our equation is in the form x squared minus 5x plus some constant that will make the trinomial a perfect square equals -4, and then plus the same constant we added to the left. Next, if a, the coefficient of x squared, is not 1, we divide both sides by a. But notice here a is equal to 1, and therefore we can skip to step 3. Step 3, we add the square of b divided by 2, or the square of 1/2 b, to both sides of the equation. This will make the left side a perfect square trinomial. Well, b is the coefficient of x, and therefore b is equal to -5. So we need to add the square of -5 divided by 2 to both sides of the equation. The square of -5/2 is equal to 25/4. We now add 25/4 to both sides of the equation. We add it to both sides to maintain the equality. Step 3 is to factor the left side, which is now a perfect square trinomial. It's not obvious here, but it is. To show some work, if this does factor, it will factor into two binomial factors. Because the first term is x squared, we have an x in the first position of both binomials. The second terms of the binomial factors will be the factors of 25/4 that add to -5, which is not an easy question, but the factors will always be the two factors we multiplied to get the 25/4. And notice we multiplied -5/2 by itself to get the 25/4. So we already know that -5/2 times -5/2 is equal to 25/4. Let's just verify -5/2 plus -5/2 is equal to -5. This sum is equal to -10/2, which is equal to -5. So we have two binomial factors of x minus 5/2. Every time we complete the square, b divided by 2, or half of b, this term here, will be the term in both binomial factors. Now on the right side, let's determine the sum. We have -4, or -4/1, plus 25/4. The least common denominator is 4. We multiply the numerator and denominator of -4/1 by 4. This gives us -16/4 plus 25/4, which is equal to 9/4. So the right side simplifies to 9/4. And notice how we do have a perfect square trinomial because we have two equal binomial factors. Let's write this as the quantity x minus 5/2 squared equals 9/4. The next step is to square root both sides of the equation and solve for x. And when square rooting both sides of the equation, it's important to remember we include a plus or minus on the right so that we get both solutions. On the left, the square root undoes the squaring, and we're left with the quantity x minus 5/2. And on the right, 3 squared is equal to 9, 2 squared is equal to 4, and therefore the square root of 9/4 is equal to 3/2. The right side is now just plus or minus 3/2. And now to solve for x, we add 5/2 to both sides. -5/2 plus 5/2 is 0. We now have x equals 5/2 plus or minus 3/2. And now we need to find the sum or difference to give the two solutions. One solution is x equals 5/2 plus 3/2, and the other solution is x equals 5/2 minus 3/2. Going back up to the sum, 5/2 plus 3/2 is 8/2, which simplifies to 4, and 5/2 minus 3/2 is 2/2, which simplifies to 1. So our two solutions are x equals 1 or x equals 4. This is how we solve the given equation by completing the square. But I do want to point out, it would have been much easier to solve this equation by setting it equal to 0 and then just factoring if we were given this option. Let's quickly show this. To set the equation equal to 0, we would add 4 to both sides. Simplifying, we now have the equation x squared minus 5x plus 4 equals 0. And now we can factor the trinomial on the left. If it does factor, It factors into two binomial factors. First term is x squared, which is equal to x times x. And because the leading coefficient is 1, we now find the factors of positive 4 that add to negative 5, which are negative 4 and negative 1, which means one binomial factor is x minus 1, and the other is x minus 4. And notice how the factor of x minus 1 is equal to 0 when x equals 1, and the factor of x minus 4 is equal to 0 when x equals 4. So of course we get the same solution much faster, but we were asked to complete the square. I hope you found this helpful.